All right, we're going to continue on with number 3. Just like we did in the last two, we want to solve our parabola for either x squared or y squared. Depends on what we have in the problem. So this one we have a y squared, so we're going to divide both sides by -3, which gives us y squared equals -1/3 x. And remember, we want this to be in the standard form so we can highlight what our p-value is. So we get y squared 4 times something. So we're thinking 4 times what gives us -1/3, and that's going to be -1/12. Okay, so 4 times -1/12 gets you back to the -1/3. So now we know our p-value. That is very small. We're going to have to be careful with this graph. Also, we have y squared. Now, in the last two problems, we had x squared, and that meant a vertical opening, because that's what we're used to when we do parabolas. If you have a y squared, that means it's going to be horizontal. It's going to be opening to the left or right. And since p is negatives, we are going to be opening to the left. Okay, so we know that we are going to be at the vertex, and we're going to open to the left on this. Now, I'm going to have to say, because 12 is so tiny. Okay, so let's make this one up here, make this 1, and this is -1, and that's 1. Okay, because I think there's 12 little boxes here, if I counted them correctly, so that means each one of our boxes is 1/12. So that'll actually make this doable. Okay, we want to find the focus, the directrix, and the latus rectum. Okay, so the focus, since we are opening to the left, our focus is going to be to the left of our vertex. So that means, and remember it's p away, so that means it's -1/12, 0. Right here. Right there. Our directrix is going to be on the other side of the vertex, and it's the same distance away, so it's going to be 1/12 this direction. And that is the line x equals 1/12. And then the last thing that we want to do is latus rectum. Remember, that's 4p. So 4 times -1/12, which it doesn't really matter, positive 1/12, because we're talking about a distance. So 1/3. So that means this whole line is 1/3, so we have to split that into 1/6. So that means a 1/6 this direction and a 1/6 this direction, and that's our latus rectum. We can put points on either end of that and draw on the rest of our parabola. All right, let's check out number 4. Same story. We want to solve for the x squared or the y squared. So we're going to multiply both sides by 4. But y squared equals 4x. And again, we need to find out what p is. So we have 4 times 1, x. So there's p. We have y squared. So it's either going to open to the left or right. It is a horizontal. And this one opens, since p is positive, it is going to open right. Okay, so we have our focus here, and we're opening to the right. I'm sorry, the vertex. I said that wrong, didn't I? The vertex is there. So we want to find the focus, directrix, and the latus rectum. Okay. So we said we're opening to the right, which means our focus is going to be to the right of this point, a distance of p, and in our case, p is 1. So our focus is 1, 0. Our directrix is going to be the other way, also a distance p away, so it's going to be 1 the other direction. There it is. That's line x equals -1. The latus rectum is 4 times p. So it has a length of 4. So from the focus, we're going to go 2 this way and 2 this way. Put endpoints at the end of your latus rectum. And finish out your parabola. Now, since we've been graphing these so much better than the first one that I initially did, you can see a little bit better how this works. So any point on this parabola is the same distance from the focus and the directrix, and you can see that one looks so much better than the first one I drew. So like this point here, here's the distance to the focus, here's the distance to the directrix, and you can see that these lines are indeed equal. Okay. We're going to be doing a few more problems with this, involving not necessarily graphing, but developing the equation from given information.